We've all experienced the benefits of crowdsourcing, whether it's restaurant reviews that help us find the perfect place for dinner or crowdfunding to bring our favorite TV show back to life. These distributed contributions combine to make some super useful tools. What if we use that same concept to build better machine learning models? Stay tuned to find out. Welcome to AI Adventures, where we explore the art, science, and tools of machine learning. I'm Priyanka Vergadia, and on this episode, we are going to examine a different approach to machine learning. Standard machine learning approaches require centralizing the training data into a common store. So let's say we want to train a keyboard prediction model based on user interactions. Traditionally, we implemented intelligence by collecting all the data on the server, create a model, and then serve it. Clients all talk to the server to make a prediction. The model and the data is all in one centralized location, making it extremely easy. But the downside of this centralized setup is that this back and forth communication can hurt the user experience due to network latency, connectivity, battery lives, and all sorts of unpredictable issues. One way to solve this is to have each client independently train its own model using its own data right on the device. No communication necessary. Great idea, right? Well, not quite, because each individual device does not have enough data to render a good model. You could pre-train the model on the server and then deploy it. But the problem with that is, in our smart keyboard example, let's say if everyone started using a new trendy word today, then the model trained on yesterday's data won't be as useful. So what should we do to utilize the goodness of decentralized data while maintaining users' privacy? Well, that's where federated learning comes in. The core idea behind federated learning is decentralized learning, where the user data is never sent to a central server. So, how does it work? Well, you start with a model on the server, distribute it to the clients, but you can't just deploy to every client because you don't want to break the user experience. You will identify these clients based on which ones are available, plugged in, and not in use. Then also find out which ones are suitable because not all clients will have the sufficient data. Once we've identified the suitable devices, we can then deploy the model to them. Now, each client trains the model locally using its own local data and produces a new model which is sent to the server. The thing to note here is that the data used to train the model on the individual device never leaves the device. Only the weights, biases, and other parameters learned by the model leave the device. The server then gets all the locally trained models and averages them out, effectively creating a new master model. But how do we know that this process is doing something meaningful and actually creating a good model? Doing this once is not enough. We have to do it over and over so the combined model becomes the initial model for the next round, and with every round, the combined model gets a little bit better, thanks to the data from all those clients. And many rounds later, your smart keyboard begins to show signs of intelligence. Now, we just saw that all the training data remains on your device and no individual updates are stored in the cloud. For additional privacy in federated learning, we can use the concept of secure aggregation, where the server pairs up devices with others in a buddy system. For example, here, each device has two buddies. Data from each device can be combined with the random values before being sent to the server. The server obviously knows the values sent to the buddies and cancels them out to just get the payload. This trick obfuscates the data while in transit to the server. If you've used Google Keyboard, the Gboard, then you have already seen and experienced a federated learning use case. When Gboard shows a suggested query, your phone locally stores information about the current context and whether you clicked the suggestion. Federated learning processes that history on device to suggest improvements to the next iteration of Gboard's query suggestion model. In this episode, we learned that federated learning is a collaborative and decentralized approach to machine learning that allows for smarter models, lower latency, and less power consumption. all while ensuring user privacy. Federated learning is still a relatively new concept, and there's definitely more to come in the future. I would love to know some of the federated learning use cases that you're thinking about. Drop them in the comments below. And I look forward to seeing you on the next episode of AI Adventures. In the meantime, if you've enjoyed this video, click that like button and subscribe to get all the latest episodes right when they come.